So you've written your first few console applications and now you want to make some games. Using Unreal or Unity for that is the easiest way to get that job done. Or is it? In most cases, game engines are way overkill for what you want to build. By using a few simple libraries, you can get stuff done without mucking about with an editor. And that is what we're gonna look at in this video.
What about now? It's time to rock with the biggity buck bumper. What about?
What you're looking at right now is the source for a simple application that loads up an image and displays it to the screen. If you compile and run this source, you'll get something like this. So what is actually going on here? In this example, we're initializing SDL, creating a renderer, and attaching that renderer to the window. This renderer allows us to draw things. For this example, we just load up an image and put it on the screen. While the image contains the actual pixel data of the file, the texture is a handle to the resource on your graphics card.
Beep, beep.
But what is an image actually made of? For that, let's first look into what color actually is. Color is usually comprised of 3 channels: R, G, and B, standing for red, green, and blue respectively. If you want transparency in your image, you need an alpha channel. The alpha channel describes how opaque your color is. If you were to assign a byte to each of these channels, you could represent 255 levels of different color for each of these channels. As per convention, you usually describe these as sets of 2 hexadecimal places for every channel. The result is a mixture of the different brightness levels for every color. This is called additive color mixing.
Chanel optics got me seeing shit.
It is in stark contrast to what you may remember from art class. When mixing different pigments, you're taking away more of the light, thus your color gets darker. If you're mixing different lights, your color gets brighter. Maxing out every color channel would give you the brightest color possible. So what we have here is the description for the color white. Since we've assigned 1 byte to each of these channels, we can describe the entire color as a singular 4-byte number, aka a unsigned integer. If you now wish to store an entire image instead of just 1 color, all you need is a buffer with as many elements as you have pixels in your image.
The recommended amount of dedicated RAM I should have to a server.
Instead of loading an image from disk, you can also generate these by yourself. By calling SDL create surface, I'm letting SDL allocate some space for my pixel data. For that, I'm passing in a width, height, and the pixel format. Once I've done that, I can start writing to that memory. The image is 500 × 500 pixels with 32 bits per pixel. Therefore, my buffer will have a size of 500 × 500 elements when using a uint32t pointer. By iterating over this buffer, I'm just gonna fill it with a constant value. In my case, that's the hexadecimal value for red. If you run this, you'll just get a red screen. No surprises here. But what if we were to add some more logic to this? By splitting the for loop into 1 for height and 1 for width, we can pretty easily tell at which pixel we're currently iterating at. Now I just have to calculate the current index by using the width of the image as well as the x and y coordinates. The next thing I'm going to do is fill the current pixel with a different color depending on a distance value. The distance is calculated by getting the differences of the x and y coordinates to the center of the screen and getting the square root of the sum of the squares. This gives you the magnitude of the distance vector. Thus you know how far you are from the center of the screen. You may also recognize this as the Pythagorean theorem. Because we're checking for 2 different distance values, we're actually getting a donut. Suck it, Andrew Price! Just kidding, I love you. Instead of drawing a static image, you can also pretty easily animate this thing. Here I've added a float value so we can tweak some of the values. Apart from that, I've also added a event loop which makes you able to properly close the window. As you can see, I'm just plugging this offset value into a sine function. Since the offset value changes for every frame, you end up having a consistent value from -1 to 1. Now, instead of having a static image, we end up having this pulsating ring effect. Instead of building static animations, we can also have interactive stuff. For this, we're loading up an image just like in the very first example. To display it at a certain position, we're gonna set up a rect.
Wrecked, son!
This will hold the coordinates as well as the dimensions of our sprite. To simulate some movement, I'm using a position and velocity here. If you're simulating movements, it's usually a good idea to have them be independent of your frame rate. For that, I'm measuring the elapsed time for the previous frame. When converting this into seconds, this gives me a neat way of just multiplying my velocity values so that they can be independent of my frame rate. This factor is usually called the delta time. If I were to render at a rate of 2 frames per second, then my delta time would be 0.5. With a movement speed of 10 meters a second, this would give me a per frame movement of 5 meters. To have some interactivity, I modified the event loop to listen for keystrokes. So if I hit the spacebar, I'm setting the velocity to 1. Or in other words, I'm giving it the upward thrust of a jump. Since we'll fall back down, I'm making sure the position won't go lower than 0. So if we hit the ground, I'm resetting both the position and velocity. Now all that's left is to convert our position into screen coordinates. For that, I'm filling it into the structure I've mentioned earlier. In the previous one, we made a sprite jump up and down. But how does that translate into 3 dimensions? Well, it's actually quite straightforward. For this purpose, I used the raylib library. Once you've figured out the logic for your movement, you can almost just copy and paste it. Heck, that's what I did here. Putting them side by side for comparison, you can see that the logic actually hasn't changed. These principles also apply if you swap out the cube for an animated model.
This shit ain't nothing to me, man. I'll kill you, you stupid piece of shit.
To do that, all you need is 2 additional lines of code to keep track of the current animation frame. For that, we're loading up a GLB model file that includes the needed animation. Just like before, we're using a variable here to keep track of the position. Then we apply our logic, update the position, and finally draw our model. So if you want to make some simple games or graphical applications, that's kind of all you need to know. I do, however, recommend that you build some simple abstractions on top of these examples. While there are some guidelines and strong opinions about that, you should really build whatever is best for your application and use case. The upcoming videos on this channel will be about game development, maybe a devlog on the game I'm developing right now, as well as a video on building your own engine. Building your own engine was supposed to be part of this video. However, I decided to make it its own video, since this one is already long enough. If you have some suggestions for video topics you would like me to cover, then let me know in the comments. If you don't want to miss any future content, make sure to subscribe. I've recently completely rebooted this channel, and I would like to use this moment to express my gratitude for the influx of new subscribers, many of whom are students from university courses I teach. A big shout out to some of my students who shared my channel around. Y'all are very appreciated. If you would like to support this channel financially, I've linked a Patreon down in the description. As of now, the tiers are kind of basic, so the main point of them is to support this channel. I do, however, offer the source code for these videos. I also added a private Discord server in which you can reach out to me. In the long run, I do plan on making more of the stuff I produce be available to my patrons. With all that being said, thank you for watching. I'll see you in the next video.